Okay, what we're going to do now is an example of the chain rule, creating a tree first and then putting every partial derivative that we have to in. I see that z is a function of x and y, x is a function of u and v, y is a different function of u and v, u is a function of r and s, v is a different function of r and s, and of course they're going to ask us for something like the partial derivative of z with respect to r or s. We'll just do r. And just a reminder, in terms of notation, what we want is that. So we're going to make a tree first, and then we're going to try to use the tree as much as possible. At the very top of the tree is z. Z is a function of x and y. Y is a function of u and v. Y is a function of u and v. Both u and v are functions of r and s. And what we want is the partial derivative of z with respect to r. So I need to find every path from the top of the tree down to r, right? Well, here's an r, here's an r, here's an r, here's an r, and we're going to talk our way through it as we go. So zr, let's just look at the first path. The first path should be zx, and then xu, and then ur, plus the second path is zx times xv times vr. The third path is zy, then yu, and then ur, and then zy, and then yv, and then vr. Now this is actually better, I think, if we can just write everything down, but I'm just going to start writing down derivatives and see what we can do. Zx, according to that thing up there, is 2x times 2 to the y. Xu is just cosine v. Ur is really just 1 over r. If you like it, it's 1 over s, yes, times s, like that. That's just the first term, because all we did was find the path down to r. The second path is going to be zx. You know, I'm not even looking at this. This is just here to confirm. I'm actually just looking at the tree and going down. Zx is what it was before. It's 2x times 2 to the y. And then I want xv is going to be minus u sine v. Like that, that's xv, and then I want vr. Vr is going to be s e to the rs. So that takes us our second path down the tree. The third path down the tree goes through y and u and r. Zy is going to be x squared times 2 to the y ln 2 times, I now want yu is just 3, and then I want ur, which as before is just 1 over r, and that takes us down our third path down to r, and then we get finally our fourth path goes through y and v and r. Let's see, so I need zy, that's going to be x squared times 2 to the y times ln 2 times yv up here is just 5, like that, and then I want vs is going to be r e to the rs, like that, and we've written down our first chain rule example that went at least 2 layers deep. You should know that, like in computer science, stuff goes 5 layers deep, so these trees can get very big, but very programmable, right? So that's not a big deal. We will try to do a couple examples, I think, over the next couple of days with data, so that you can see that you have to have a tree. You can't just keep plugging in all these functions into the bigger ones and actually have it work in the end. So that's our example.